Hello everyone. AAT concept video DS data structures. My name is M. Krishnavaran. I'm from CSIT second year. My topic for AAT concept video DS data structures is demonstrate insertion sort. Introduction. The idea of the sort is similar to the idea of sorting the playing cards. Insertion and sorting. It is a simple sorting algorithm which sorts the array by shifting elements one by one. Following are some of the important characteristics of insertion sort. It has it has one of the simplest implementation. It is effective for smaller data sets but very inefficient for larger lists. Insertion sort is adaptive. That means it reduces its total number of steps given a partially sorted list, and it increases its efficiency. It is better than selection sort and bubble sort algorithms. Its space complexity is less, like bubble sorting. Insertion sort also requires a single additional memory space. It is stable as it does not change the relative order of elements with equal keys. Let's take an array 5, 1, 6, 2, 4, and 3. As we can see here, in insertion sort, we can pick an key and compare it with elements ahead of it and puts the key in the right place. 5 has nothing before it. 1 is compared to 5 and it is inserted before 5. 6 is greater than 5 and 1. 2 is smaller than 6 and 5 but greater than 1. So it is inserted after 1. And this goes on. Always we start with the second element as key. Just a short example. Here is an array 9, 2, 7, 5, 1, 4, 3, 6. We start by dividing the array in a sorted section and an unsorted section. We put the first element as the only element in the sorted section and rest of the array in the unsorted section. The first element in the unsorted section is next element, but we put in the correct position. So we copy the element to be placed here in the another variable so it does not get overwritten. The previous position is more than the item being placed. Copy the value into the next position. If there are no more items in a sorted section to compare with, the items to be placed must go at the front. Here it is. 2 is in front of the 9. So 2 is in sorted position. So the next item to be sorted is 7. 7 is is less than 9 but greater than 2. So we swap 7 with 9. Here it is 279. Next element is 5. 5 is smaller than 9 and 7. So we sort it. 5 is smaller than 9 and 5 is smaller than 7. But 5 is greater than 2. So it comes after the 2. So it is sorted 2, 5, 7, and 9. Next element is 1. 1 is smaller than 9, 7, 5, and 2. So it comes at the first in the order 1, 2, 5, 7, and 9. The next element is 4. 4 is smaller than 5, 7, and 9, but it is greater than 1 and 2. So it comes next to the 2. So it is sorted 1, 2, 4, 5, 7, and 9. The next element is 3. 3 is smaller than 4, 5, 7, and 9, or greater than 1 and 2. So it comes in front of next to 1 and 2. So it is sorted again 1, 2, 3, 4, 5, 7, and 9. The next element is 6. 6 is smaller than 7 and 9, but it is greater than 1, 2, 3, 4, and 5. So it comes in the place after 2, 5. So it is sorted 1, 2, 3, 4, 5, 6, 7, and 9. So it is a sorted array. We can see that all elements in the array are sorted in the terms of numbers list. We can see here the way of working. The way of working of the selection, insertion, sort is select, compare, shift, and insert. As you can see here, there's an example. You have to select a number. You have to compare the number with the before elements. If the before element is greater than the select elements, it should be shifted and inserted there. So we should do the same process with all the elements. So this is the way how the insertion sort is working. Thank you.